problem number 1. I did write on the review yesterday. I wanted to see how everything lined up with the test. So like problems 1 through 3 are also problems 1 through 3 on your test tomorrow. The rest of them are all kind of like mixed up, but every single type of problem you see on this review, you will see on your test. Okay, so they'll all be similar. They're just going to be in a different order, but it's all the same stuff. For this section here, you should be able to use the asterisk for each of those. That's why it says solve by factoring. If they wanted you to use quadratic formula, it would say it, okay? The only thing you have to remember, they have to be set equal to 0 first. And you guys will see tomorrow when I give you your test, I made notes on the test for you. So it'll say, like on this problem, it'll say set equal to 0 first, just so that way it reminds you. But for this one, since it's already set equal to 0, we would have -30 and then a -1 at the bottom. The two factors. 5, -6. So then your two sets of parentheses would be n plus 5 and n minus 6. And then just make sure you finish by putting your two answers. And these are just one step each, so you don't have to really show any work for that. You just know that if this says plus 5, you'd solve it by subtracting 5 from 0. So this answer ends up being -5. And that should not be written in parentheses. That should just say n equals -5. Well, let me tell you about that later. Don't worry about making a page of notes right now, okay? This one right here, if it says -6, you'd add 6, so that's going to make your second answer a +6. Are we good with that one? They don't get any easier than that one, because that one's already set equal to 0, so that's straightforward. On number 2, we would have to add 42 to both sides. It's not really necessary to show that since it doesn't have anything to pair up with over here. But if you don't show it, you still have to make sure that when you write these three terms, you still have to make sure you put them in the correct order and that you change that -42 to a +42. Because if you try to use a -42, you won't get it to factor. So +42 up top, -13 at the bottom, and then you've got 1r. What are your two factors?
-6 and -7.
So nice not having that register. All right, so we've got r minus 6, r minus 7 equals 0. So then my two answers are going to turn into positives. So you have r equals 6 and r equals 7. Order doesn't matter just as long as you have both of your answers on your paper. Okay? Are we good? Okay. Number 3 is the hardest one because not only do you have to move two terms over, but then you also have a 2 out front. So when you go to do your asterisk, you'll have to remember to multiply the 2 by the number at the back. Okay? So I would add a 1b. Make sure you line that up with the -6b. And you're going to subtract 4 and line that up with the +1. So 2b squared comes down, -6 plus 1 is -5b. And then 1 minus 4, -3. So if you were to draw your asterisk right now and just put -3 at the top and -5 at the bottom, it would not factor, and that's because you've got this 2 out front that you have to multiply by. So 2 times -3 would be -6. Then you have the -5 at the bottom. And now instead of 1b and 1b, it's 2b and 2b. I did notice a couple of you yesterday used 6 and 1. No, sorry, used 2 and 3. And you made them both negative. Well, -2 plus -3 does add to make -5. The problem is when you multiply two negatives, this would have been a positive. So it wasn't 2 and 3, it was actually 6 and 1. And the bigger one has to be the negative because the bottom's negative. This does not reduce, so I left that as 2b plus 1. This one over here does reduce to what? Yep, 1b and negative 3. So you'd have b minus 3 equals 0. This set of parentheses, that one, I would say most of you are probably just going straight to your answer because it's a one-step equation. So you'd end up with b equals positive 3. This one, however, that is not a one-step equation. So you can't just say, well, b is going to be negative 1 because we've got this 2 out front. This is the only one that I tend to show my work on because it's a two-step. We'd subtract 1. I'm going to run out of room, so I'm going to go over here to finish this. This is 2b equals negative 1, and then you still have to divide by 2. How many of you guys are leaving your answers as fractions? Is anybody? The rest of you doing decimals? Okay, it really doesn't matter how you write it. If I see this, I leave mine in fraction form. I don't bother typing it in, but if you do type it in, it would just be negative 0.5. So it doesn't matter whether you write it as a decimal or a fraction, whichever you prefer. So do you guys have any questions over the problems at the top? Factory. We're all good? I'm ready to talk. Okay. I'm not going to do number 4 yet. I'm just going to talk about it. So number 4 does say quadratic formula. The quadratic formula is on your reference sheet, so you've got that you can always have. I think on your test I wrote it out here to the side just so you didn't have to keep looking back and forth between your test and the reference sheet. But it does say write the answer as exact. So that means if your number under the radical, if it breaks down using a factor tree, you have to do that. So they're just telling you not to write your answer as a decimal. This one still has to be set equal to 0, right?
Yes.
So what do we move?
You subtract 1 from both sides.
So 10x squared plus 6x minus 1.
Mm-hmm.
Okay, then we've got a is 10, b is 6, c is negative 1. I am still trying to get in the habit of finding my discriminant first, but I don't know if you guys are. Are you just plugging it all in at once to the quadratic formula? Okay, so I'll just do that then. So x would equal, opposite of b goes first, so negative 6 plus minus. Then you've got, I make my radical pretty big here because I'm going to put the b squared minus 4ac under there. So the original value of b was 6. I'd square that. Minus 4 times a, which is 10, times c, which is negative 1. Fraction bar under the whole thing, not just the radical. It's under the whole thing. And then on the bottom, it's 2 times a, which is 10. The step after that, though, if you guys are doing this all at once, you should just type this part, like just type in the b squared minus 4ac into your calculator, and then I always multiply out the bottom. Everything else would stay. What did you guys get in here?
I got 76.
I'm going to get 76. Yeah, you know what you did? You didn't square the 6. So see how it says 6 squared? You must have just put a 6 and forgot to square it.
Oh no, it's because I forgot the parentheses.
Yeah, you're fine. Okay, so if you looked at your factor sheet and 76 did not break down, then you would just leave it, and this would be your final answer, right? But there is a factor pair that one of them is a perfect square. Is it 4?
2 and 38.
But 38 isn't a perfect square. So I used,
2, 19.
so it's 4 and 19. No, I think you still got the right answer. It's 4 times 19. So the square root of 4 is what? 2. And then the 19 would stay under. So this, like I feel like somewhere on your paper you might have that. This right here is going to replace this. So I would have -6 plus or minus 2 radical 19 over 20. And then again, you're like, oh, okay, I'm finally done. Well, not if this, this, and this, if all 3 of those have something in common. Yep, everything's just going to get cut in half. I know, I don't really have much room either. So listen, if you guys find tomorrow when you're working on these problems, if you need paper, there's a whole stack of paper over there on that table. Just work some stuff out on paper and then turn it in with your test. But this would be, I'm going to write my final answer over here. X equals -3 plus or minus. Are you guys making this a 1 or are you just leaving it off?
I put a 1 right there.
Yeah, I always put a 1 there too, but you never need 1s in front of radicals. So if you didn't want to put the 1, you wouldn't, I mean, you don't necessarily have to. All right, there it is. That's reducing by 2 at the very end.
Fairly high record.
Okay, you guys feel good with that? Number 5 ends up being a problem that, like what I taught you yesterday. So a quadratic application type problem. Now, yesterday, I want you guys to understand, yesterday, every parabola we were doing was upside down, right? And when it was upside down, they kept saying max profit. Because if it's upside down, the vertex would be at the top. Is this parabola going to be upside down? If it's a +4 out front?
No.
This one's going to be facing up. That's the reason they say lowest profit. Because with a parabola facing up, the vertex is at the low point. It does not change how you do the problem. So I wasn't sure if you guys would get confused because yesterday we were talking max. This one says lowest, but it's just because the direction has changed. It doesn't affect anything else in the problem. So when it says find the lowest profit or what was the lowest profit, we still need to figure out that axis of symmetry. You guys remember the -b over 2a? That's what you're going to start with. So the opposite of b would be 8. And then on the bottom, you'd have 2 times 4, which means you're taking 8 and dividing by 8. So x is 1. And then what do I do with that 1? If they want to know the profit.
You plug it in.
Yeah, we're doing like a plug and chug now. So once you get x, you just do a plug and chug.
For the next one, right?
No, that's still part A. Because this right here is just, I'm sorry, wait. They said profit. So you have to solve for P. So the first thing you have to do is find X. So that way we know what number to do the plug and chug with. So we're going to do 4 times 1 squared minus 8 times 1 plus 96. Did anybody get an answer for that? What'd you get? So it ended up being 92. However, what is the profit measured in?
$1 million.
Right. So you need to either, like, I just wrote the word million. You could put 6 zeros after it if you wanted to, but I just wrote 92 million
I wish I had the like lowest profit of 92 million.
That's because this was written all there, and you probably thought that went there. Okay, now, letter B says, what year did they experience that lowest profit? Well, look, it says, if X is 1, that's how many years after 2018. So, if it started in 2018 and a year later it hit the lowest profit, just add 1 to it. So that answer of 1 that we found for A, we're just adding to 2018.
Okay, so
2019. So X, when we found X here, that represented how many years after 2018 it hit that profit. That's what that was. So right here it says, what's the expected profit in 2024? Well, how many years after 2018 is 2024? Yeah, so if you guys didn't know this, if you didn't know it was 6, you're just subtracting those. You're taking 2024 minus 2018. So that's going to happen 6 years later. So what do I do with that 6?
You plug it in for 8.
Yeah, I do a plug and chug again, but instead of plugging in 1s, I'm plugging in 6s. So I'm just redoing part A and using a 6 instead of a 1. 192? Caleb? I can hear that. 192, but then make sure you stick million after it, since we are talking profit. Do you guys want to know, the problem numbers they match up with on the test? Because like, let's just say, for instance, let's say tomorrow you made a page of notes and you wrote number 5 on there. Well, what if it's not number 5 on your test? Wouldn't you rather know which number it is so you know which one to refer back to? You do. Okay. All right, so problems 1 through 3 are problems 1 through 3 on your test, okay? So those should match up just fine. Now, does it necessarily mean that these two right here, you're only going to have to move one number on number 2? Not necessarily. It's just the same type of problem, okay? Number 4 does match up with number 4 on your test. Those are the same. But number 5 is actually the very last problem on your test. It's number 22.
22.
Mm-hmm. It's number 22 on your test.
That is ridiculous.
It's pretty common for a unit exam to have in the 20s. Okay, whenever you're ready, flip it on over and we'll work on problem number 6.
I feel like the only one I'm going to struggle on is the word problem.
It's okay. You'll be fine. Okay, number 6 matches up with number 6. So I'm going to go ahead and write that number 6 on test. Okay, so on number 6, it says use the quadratic equation to answer these questions. As soon as I see this, when it's asking like discriminant, and I know I'm going to have to use quadratic formula, it still has to be set equal to 0, right?
yeah.
So you still are going to have to like add 1x. You're going to have to move that term over. And then subtract 8. I don't know if you guys did it that way or if you moved them the other way. Doesn't really matter. I like the x squared term to stay positive, so I probably would have moved it the other way, but negative 4x squared. These two combine to make negative 2x in the middle, and then that minus 8 didn't pair up with anything, so you just put that at the end. And now we can find our discriminant. So even on your test tomorrow, you guys are going to see this. Like I wrote that in that space. You'll see it in my handwriting. And then that way it reminds you, okay, this is how I find the discriminant. So what is B?
-2.
No, B is -2 squared, and then -4. What's A?
-4.
-4, and C, -8. And then you guys just type that whole thing into your calculator. And you end up with -124.
Barry, this is not the answer to that issue.
Yes, that.
It was, because you guys kept telling me -124, and I said, remember when it's negative, it's two imaginary
You
numbers.
said you didn't have the negative.
Yeah,
sign in
you
front
yelled
of
at her for
Yeah,
not
you
having the
forgot
negative
the
sign.
negative
But you still have 124.
it. That is.
It is, it's -124.
I thought you said.
Yes, you're 20 for her.
Okay, so then, anytime you guys have a negative discriminant, it's always two imaginary solutions. Two imaginary, you can say solutions, you can say roots. I know on the answer key, if you guys looked at the answer key yesterday, it said two imaginary, no real. I don't need that. I always tell you guys to either put one real, two real, or two imaginary. Okay, so this was my answer. Two imaginary roots, or two imaginary solutions. And now we can do the quadratic formula. So when you plug this into the entire quadratic formula, here's the good news. We have already figured out that under this radical, we have a -124, right? So we already did like the hardest part of the problem. Opposite of B goes here. So that would turn into a +2. And then on the bottom, you have 2 times A, which is -4. See, this is why I don't like my A to be negative, because then I end up with a negative number on the bottom of a fraction. And normally we don't put negative signs on the bottom. So I don't usually write it that way, but it's still correct. Does 124 break down? Oh, I bet it does. 4 and 31, right? What's the square root of 4? So a 2 will come out. The 31 is going to stay in, but what else do I have to attach to that 2? Try again. The I, because this was a negative. So we're going to have 2I radical 31. You can't leave out that I. If you guys have a negative under the radical, your answer should have an I in it. And then 2 times -4 is -8. That would be your final answer if it didn't reduce. But it reduces, of course. 2, 2, and 8. All divisible by 2, right? So I'm just cutting everything in half except for the 31. The 31 under the radical can never be touched. Number 7 matches up with number 5 on your test. They give you a lot of space on number 7, which is completely unnecessary because all you're doing is finding the discriminant. So you're really only doing b squared minus 4ac. However, it's not set equal to 0, but even moving that -2 over, you're just adding 2 to the 8. You're not doing a whole lot of work. The unfortunate thing is since these tests were all created as PDFs, so I can't even, like I can't go in and edit it. I have to leave it as it is. Plus 10. Yep. So then when we do our discriminant, the B is -3. And then the A is -5, and the C is 10. Should get 209. Now, if you hadn't already had this problem done, I would at least right now type this in and make sure you get 209. Because if you don't, you know, we'll need to figure out what you're typing in wrong. But anytime that you have a positive discriminant, it's not two imaginary, it's two real roots or two real solutions, however you want to say. Two real roots, two real solutions. Doesn't matter.
Tell me how you, the next time you tell me how you got that answer.
You never figured that out.
Oh,
Are we good
I did.
with that one?
Because she helped you. Shut up.
But I mean, does everybody understand what I just did there? No. It's opposite, same.
Oh.
Yeah.
Good try though. You guys, this one is super simple. When something is given to you in vertex form, and I think they're setting you up for number 9, because isn't number 9 or 10 in vertex form, the one you have to graph? So they're setting you up for 9 and 10, because if this is in vertex form, we already know the vertex.
Oh.
I just realized I didn't even tell you what to do on this problem. Number 8, there should be directions that say, what is the vertex? Did you guys notice there were no directions? Nobody? Yeah.
That's why I was confused.
Okay, so the vertex is found by opposite of this one. So the one paired with X is always becomes opposite. The one outside always stays the same. So you are just choosing, let me write this. So we are looking for the vertex, okay? The opposite here and the same here. So the opposite of 9, -9, so it's one of these two. They have the same answer twice.
Yeah.
Goodness gracious.
I just saw it.
Well, I bet you one of them was probably supposed to say -5 and it was left off of there. But, yeah, there should just be one answer. This is,
so funny. You helped me yesterday and then you were like,
this is number 9 on your test. Yeah, because I just looked at the problem and just said it's -9 and 5. But see, look at her answer key. She changed them.
oh.
She changed that one. See? I'm not crazy. Well, I'm crazy, but
I'm crazy.
not
I'm
your
that
fault.
crazy.
it's not my fault. I didn't do this, I swear. I didn't make this.
I swear, it's not my fault.
That's what I get for not looking. I've been trying to do 2 days ahead at a time so that I don't feel overwhelmed. And I just overlooked that. It's not a big deal. But that's number 9 on your test. Okay, how do you guys feel about that one? Good?
Yeah.
Okay. Number 9's another one that printed wrong. If you guys actually looked at the answer key on 9, there was a graph here that you were supposed to use to answer the questions. I don't know what happened to it. It disappeared when I printed this. It's just gone. So when it said use the graph below, I told you guys, do 10 first, graph it, and then just answer the questions up here after. That's not really how it was supposed to be done, but that's all we could do. So I'm going to go down here and just graph this one. This matches up to number 12 on your test. See, this is why I don't want to record all my lessons term 1, because this is the first time going through this. Term 2 and term 3, all these little things will hopefully be worked out by then. All right, is this one going to open up or down? Because it's negative out front, right? Okay, so it's down. Now to find your vertex, make this one the opposite when you write it and keep this one the same. Yep. And then your axis of symmetry, you guys just know it because it's the x coordinate of your vertex. So you simply just write x equals -1. That's all you have to do. I think I drew the t-chart on your, on your copy of the test tomorrow. I will have already drawn that t-chart for you. Okay? But the top one, the top row, is where we can write our vertex. So I'll put -1, 1 right there. I would like you guys to go ahead and plot that. If you haven't done this one yet, you're going to plot -1, 1, and then draw in that dashed line we usually draw. Now it's your choice. You can pick either -2 and -3 for your other x values, or you can use 0 and 1. Whichever ones you guys want. See, I would have used 0 and 1 because they were 0 and positive. Because we haven't typed anything into the calculator yet. Now, if I had already typed in a -1 into my calculator, I would replace it with 2 negatives. But since I haven't typed anything in yet, I probably would have typed this in with a 0 and then a 1. They would have been just a little bit easier. Either way, it doesn't matter. This that I'm showing over here, this is what you would type into the calculator. So it is the original function, just replacing the x with a -2. So this is the one that we're changing. And then I would replace it with a -3. Did you guys get -1 and -7?
Yeah.
Well, type it in and see if that's what you get. So this is the calculator stuff right here. You don't have to show that on paper. You can, but you don't have to. So -2, -1, and -3, -7. And hopefully by now we all know how to mirror our points. This one right here is 1 to the left of the axis. So start at the axis and count 1 to the right. And then this one down here is 2 to the left. So I start at the axis and I count 2 to the right. And now you have the 5 points you need for your parabola. Okay, we good? Now some of the parts of 9 we've already done because it asks for vertex and axis of symmetry again. But that's okay. So on number 9, part A, what'd you guys put? -1, 1. Which means your axis of symmetry is x equals -1. Letter C asks for the Y-intercept. So if you look at the graph at the bottom, where did it cross? Didn't it cross at -1? Yeah. So I would have written it as 0, -1. Y-intercept should always start with zeros. Now the x-intercepts you guys can't do because now, ooh, that's a terrible line. If you guys actually had the right graph, like if the graph that was supposed to be here was there, you would have been able to tell me where it crosses because it crossed at, looks like it crossed at -5 and 1, but you didn't see that. So when you look down here, can you tell where it crossed the x? No, because it's in between. It's like in between numbers. So I just told people not to do this one. I don't know how to make that go away. Like, I don't know how to close that.
Try dragging it out so that it'll actually take the text out.
It won't do anything. Well,
Like, if you put-
hey, we're just gonna have to make this work. It'll be fine.
I think the circle key.
It's okay.
Huh? I think the circle key.
Okay, the domain. Okay, so you guys have a couple options, right? I told you guys you could write all real numbers. I also said you could make this symbol. It does say to write an interval notation. Interval notation is the one where I said when you say all real numbers, it's negative infinity to positive infinity. You guys, I don't really care. I'm not going to take off if you don't write it in interval notation. Now, for the dual credit students, if you were doing this at Ivy Tech for pre-calc, you'd have to write the interval notation. And then for the range, again, I'm not going to write it in interval notation, but the range is always y. Is my parabola going up or down?
Down.
So it's less than or equal. And then the y coordinate of our vertex was, no, it was positive 1. The y coordinate was positive 1. This is so annoying. Hang on. You told me to like minimize this.
take-
See, it's gone. But when I open this back up, it's there. Oh, no, it's gone. Yay. Woo.
Magic.
Magic. Okay. This was number 11 on the test.
Number 12 to mine.
Yeah, so this is 11, this one's 12. Nope.
You should let us use all of our notes, please.
We're just using the
I'll
review
ace the test if you
on
do.
the test.
Yeah.
Oh, I didn't say that. I didn't say that. I haven't told you anything about that yet. We're just getting all this review done so you have something to study tonight. Okay, we good? All right, turn the page. We've got one more to graph. This is the harder one because this is standard form. This will match up with number 13. He's growling at me.
What is?
Caleb.
She said what is.
Don't growl at me, Caleb.
Minute.
It's not my fault.
It's going down.
Okay, number 11. This is standard form. Negative means
Down.
down. You can either circle it or you can write it. I don't care. Now, the axis of symmetry. Unfortunately, you have to find it because it's not in the, we don't know the vertex yet. So the axis of symmetry with standard form, what do we do?
Negative 12.
No. Well, that's what you start with. It's negative b over 2a. So it will be negative 12 up top. Then on the bottom, it would be 2 times a, which is negative 2. So negative 12 divided by negative 4? Mm-hmm.
It would be negative 3.
Positive.
I only got that one right.
Oh, I didn't. Yeah, negative on the 12.
So the 12 originally in the equation was positive, but when you plug it in, you have to do the opposite. So just make sure you remember to do it.
Oh, is that just because we didn't solve for 0? That's why the axis of symmetry.
No, when it's in vertex form, when it has the parentheses, you already know the vertex, which means you know the axis of symmetry. This does not have parentheses. So when it's in standard form, you have to do this. You have to do the negative b over 2a. Now, if we know that x is 3, this is what I know so far. I know my vertex is going to be 3 comma something because we already know x. The problem is we don't know y. We don't know what the value of y is. How do we always find y if we know x? Like Glade.
Plug it in.
We plug it in. Yeah. Yes, we plug it in, right? So we're going to plug it into this one. How many times do you see that letter x? I see it twice. So you need to make sure that you plug in the 3 here and next to the 12. So you could just type that whole thing into the calculator at once, and then finally we'll be able to graph this thing.
2.
It should be 2. So your vertex is 3, 2. Now I know some of you got letter D off of the answer key yesterday. It says, what is the y-intercept? Now just think for a second, because we haven't even graphed this thing yet, so I don't know where it crosses the y-axis. However, listen, y-intercepts is when x is 0. Well, if I plug in a 0 here and a 0 here, what happens to those two terms? Don't they just disappear? So isn't it just negative 16?
Yeah.
This constant is always your y-intercept. It's always your y-intercept. So the y-intercept would be 0, negative 16.
So the
And-
last number is always.
The constant, yep. The last number will always be your y-intercept. And even if I were to graph it, is there even a negative 16 on this graph? So you wouldn't be able to see it. So you have to know that your y-intercept is right there in the equation. Okay? All right, now let's graph this thing.
So this isn't when we do the bracket thing.
No, I don't think, if I'm thinking of what you're thinking, then no. So I think on your test, I drew in the chart for you. The bug. I know. They're even in my house. Makes me feel dirty, but I'm not. But like they're everywhere. They're those little like fruit flies or whatever. Little gnats. Mm-hmm. Okay, so our vertex was 3, 2. So write 3 up 2, and then do your axis of symmetry there. So if that's at 3, you guys have options. We could do 4, 5, or 1, 2.
4, 5.
Sure, sounds great. The 4, did anybody do 1, 2? No? Okay. Well, your 2 would have matched up with my 4, and your 1 would have had the same answer as my 5 will have. But you already have, or you should already have this typed in once from when we did it here. So now what we're doing is we're just replacing the 2 3s with 4s, and then you're replacing them both with 5s. So I'll write that out here to the side in case you refer back to this later. But you don't have to write this on your paper.
The 4 is 0 and then the 5 is negative 6.
And then just plot those points and mirror them. So 4, 0, and 5, negative 6. So then we'd have 2, 0, and 1, negative 6. Now that one, if I asked you for the x-intercepts, you can see those, can't you? It'd be at 2 and 4, because that's where it crosses the x. Just that other problem we couldn't tell. Whew. Number 12 is another problem that we did yesterday. I think it's the last quadratic word problem. So Jade, I think you were the only one not here yesterday. So Jade, number 12 is also one that like you would see on what we did yesterday. All right, number 12 matches up with number 14 on your test. Okay, first thing you should always do on this word problem, somehow, and I don't know if you guys have highlighters or not, but even if you don't, just make sure you know where that function is, because we're going to be using that function up there quite a bit. We have a height and we have a time. Jason launched a rocket from the top of a building to see how high it would go. The height as a function of time could be modeled by this. T is the time in seconds and H is the height in feet. First question, what is the height? So we are solving for h when the time is 5. So what do I do with the 5?
Put in place of the t's.
We're just plugging it in where the t's are. So negative 16 times 5 squared plus 16 times 5 plus 672. And whatever you get for your height, please put either the whole word feet or ft at the end of it. You should get 352. So just double check and make sure you do.
You said 352?
Mm-hmm. Okay, letter B says, how long did it take to reach max height? So the time to get to the top is your axis of symmetry. So that time is the negative b over 2a that we usually put x equals, but in this case, x is time, right? Or time is x. So the opposite of b would be negative 16. And then 2 times negative 16 on the bottom. So you end up taking a negative 16 divided by a negative 32, which is 0.5. And that's in seconds. And we talked about that the other day, about how something taking like half a second to reach max height makes sense. And then we redo part A where part C is, except now we are not going to use 5 seconds, we're going to use 0.5 seconds because they want height. So h equals negative 16 times 0.5 squared plus 16 times 0.5 plus 672. And you should get 676 feet. Oh, we're almost done. These, well, the last 2 pages take way less time. All right, letter D. How many seconds will it take to reach the ground? Well, at ground, what's the height?
0.
Yes, finally, we said the right answer today. So when it reaches the ground, that's when you just set the function equal to 0. And we're going to have to factor. But we don't like it when there's that negative 16 out front, so what do we do with it? We factor it out, which means we divide. We're going to divide everything by that negative 16. So yes, you're kind of dropping it. You're just getting rid of it, but that means factor it out. So if you don't know what I'm doing right now, I am just dividing each of these terms by that negative 16. 42?
Yeah.
Okay. I
Okay.
just
Do
guessed.
we have to put the 1 in front of the t, or can we put t?
No, you can put minus t. You just have to know that it's a negative 1 when you do the asterisk. Because then when you do the asterisk, now you don't have to worry about this negative 16 anymore. You're just concerned with the numbers inside the parentheses. The negative 42 and the negative 1. So to make 42, 6 and 7, and the bigger one has to match the bottom. So the 7's going to be your negative, your 6 is going to be your positive. Now, technically, this negative 16 out front is still there, but it's not going to affect these answers at all. So this t would equal what? 7. Now 7 is a completely acceptable answer. This one is going to give me negative 6, which does not make sense, not for time. So we cross out the negative, and the only answer we have is the positive 7 seconds. Now, we talked about this yesterday. If you guys get 2 positive answers, leave them both, because it can hit a certain height going up, and it can hit that same height coming back down. So you might get 2 positive times.
So
Okay?
basically the two real roots.
Okay, are we good? All right, as soon as you turn the page, we're getting into the operations with complex numbers. So we're going to add, subtract, multiply, and divide the complex numbers. And those tend to go a little bit quicker because there's not nearly as much work that needs to be done like we've been doing. 13 through 16 match up to 15 through 18 on your test. And then number 17 is number 20 on your test, if you want to just go ahead and write that down while we're here.
So number 15 through what?
18. When you guys get your test tomorrow, this is what you're going to see. On this problem right here, you're going to see this next to it. What does that mean? No.
What?
CLT?
Oh,
Combine.
like
Like terms.
Okay. I wrote CLT there just reminding you. Just combine. So negative 7 plus 3.
That'd
A
be
negative 4.
Negative 4. And then 6i plus 4i is 10i. Easy peasy.
I always do a change. Oh my gosh, I just got it.
Number 14, with subtraction, I wrote this on your paper. I wrote KCC for keep, change, and then CLT. So you're going to first do keep, change to turn it into an addition problem, but then we're just going to do exactly what we did on 13. So I'm going to change this to a plus. My 6 will become negative, and my negative 2 becomes positive. So that's my keep, change step. So when you
So do you
keep, change,
change,
uh-huh.
change positive 4 and then
No. The first set is your keep. And then the change starts there in the middle, and then you change both of those. Okay, so negative 6 plus negative 6 is negative 12. And 4i plus 2i is 6i. So it's negative 12 plus 6i. This one right here, like 13 would just be 2 points. 14 would probably be 3 points because you have to do the keep, change first. But then 15, what kind of problem is that? So it's the box problem. I wrote the word box on your test to remind you, since it's a 2 by 2, we are going to make a square, and we're going to cut it into 4 pieces. We're going to do, I did negative 5 minus 6i across the top, and negative 4 plus 7i down the side. That's how I did it. You could have put it the other way. So negative 4 times negative 5 is 20. Negative 4 times negative 6 is 24, and then don't forget the I. So that's just the top row. When you switch to the bottom row, make sure you are taking positive 7 times negative 5. So it's negative 35I. And then be careful of this corner box. We've got 7 times negative 6 is negative 42. But then it would have I squared attached, which would turn it into positive 42. You drop the I squared and you just make it its opposite. So then we can add 20 and 42 to give us 62. And then what's negative 35I plus 24I? Negative 11I, yep. That's your final answer.
Why did you put negative 42i?
So you
When you do 7 times negative 6, it's negative 42, but the I squared would make it become its opposite. So in your final answer, there is no I there. The I squared disappears and turns that positive. That's why I always write this on the outside, because this is not what we use. We turn it into positive 42. Huh, you know what else is 42? Me, tomorrow.
happy early birthday.
Thanks.
Did you add them like diagonally?
Yes.
Okay.
So after you do the multiplication, you are just combining like terms. So I did 20 plus 42 and this plus this to get that.
Oh, okay.
Do you guys remember conjugates?
Nope.
Come on, you have to use it on the division problem.
Well,
So look, just look at this problem. When you guys change this into multiplication, what do I multiply the bottom by?
1, 4.
you're guessing a good one.
You guys all did this on the day. There's only one symbol that changes. Which one?
The I.
This one. The one in the middle, you turn into a plus because it started out as minus. And whatever you multiply the bottom by, you multiply the top by. That right there is the conjugate of this. Yeah. I'm not doing that problem right now. I was just using that as an example as to number 16. When they ask you for a conjugate, if it says 5 minus 8i, we just write 5 plus 8i. It's just the opposite operation. So you might want to make a note of that. Just put change operation. So if it's a minus sign, turn it into a plus sign. If it's a plus sign, turn it into a minus sign. That is the only thing that changes. Now see on your test, see how this is number 16 here? On your test it's number 18, and guess what number 19 is? The division problem, where you have to use the conjugate because they're setting you up for it. On the review, there's a problem in between it. But yeah, 16 will help you with 18, or 18 will help you with 19 on your test. All right, this one, isn't this still a multiplication problem right here? Well, when they multiply, they don't use the box method. They just distribute. So what I wrote on your paper is to use the box. So go over here, draw your little box, do the multiplication like we just did on number 15. So we'd have 4 plus 3i times 2 minus 5i. Go ahead and fill out those boxes for me on your own paper. So when you guys do 2 times 4, you get 8. And then you would do 2 times 3i, which is this 6i. Negative 5i times 4 is negative 20i. And then the bottom right-hand corner, negative 5 times 3, negative 15. But it would have the I squared attached. So this just gets turned into a constant of positive 15.
How did it get the square attached?
Because I times I is I squared.
Oh, okay.
Because remember, at first we're multiplying, but now we're going to just add stuff together in here. So I'm going to do 8 plus 15, which is 23. And then I'm going to do negative 20 plus 6, which is negative 14i. That right there is the correct answer that goes down here on this answer line. But they love to ask you questions like, okay, somebody worked this problem out, they did it wrong, they wanted you to work it out yourself and find where the mistake was made. Okay, so when I start looking through here, even though theirs was done differently, all their same terms will be here. So please watch. Please make sure you guys are paying attention. Here's an 8. Here's an 8. Negative 20i, positive 6i, and negative 15i squared. Well, I did have that at one point. So clearly step 1 was good. Okay? Step 2. They left the 8 and they left the negative 15i squared. So we still have 8, negative 15i squared. And they combined these two. Well, didn't I get negative 14i like they did? Okay, so step 2 is still good. Now on step 3. They left the 8, they left this, but then look what they did here. They didn't drop the I. So they had negative 15i squared. They remembered to turn it positive, but then doesn't that I squared disappear? So this I should not be there. They didn't drop, they dropped the squared, but they didn't drop the I. So right here I just wrote in step 3, negative 15i squared should equal positive 15, not 15i. So you just need to tell me what the mistake was. And then, you know, you can rewrite this answer down here on the answer line, or if you guys just draw an arrow like I did, that's fine too. I don't really care either way. Just as long as I see the answer somewhere. Still feeling okay? We don't have much more to go. Got like 4 problems. 5 problems, I guess. Number 18 at the bottom is just like number 19 on your test. Now, I already talked about, you know, when you guys have division, we don't ever divide. We're not allowed to have i's on the bottom of a fraction. So to get rid of the I on the bottom, we multiply by the denominator's conjugate. So this number stayed the same. It's just the operation that changes. Okay? And whatever you multiply the bottom by, you have to multiply the top by. So how many boxes will I need for this problem? I'll need 2 boxes. I'll need a numerator box and I'll need a denominator box.
Wait, but if there's 4 at the top, then how did you get 6 at the top?
Because look, this is what we're multiplying by. You change this one, and whatever you multiply the bottom by, you multiply the top by. These two are always going to be the same. When you do your multiplication, though, we're going straight across. So I'm going to have a numerator box, and I always label it because Whatever you get out of this box is going to go on top, and then whatever you get for the denominator box, that's going to go on the bottom. So this will go here, and this will go here. All right, my two numerators. -4 plus 4i, and then -6 plus 6i. Oh, I didn't leave much room. -6 minus 6i, and -6 plus 6i. Those are your two denominators. Watch your signs, because you have lots of negatives and positives being multiplied together. Oh, that was a lot.
Wait, how'd you get -24?
Because this would have been positive,
Oh.
but then the I squared would turn it negative. Now, this isn't something that typically happens, you guys. Typically, the numerator, these two don't usually cancel each other out. It just, they happen to cancel each other out this time. What's a -24i with another -24i? You're adding.
-48i.
Yeah, -48i. And then there's usually like a plus something, but 24 and -24 would cancel each other out. It'd make 0. So these two don't even matter. Now, if it was like 24 and -10, you'd put a 14. Normally, we have two terms up top. That's what I'm getting at. But here, we're just going to have one. And then the other one, looks like I have a 36, a 36i, -36i. And then this would start out as -36i squared, which would turn into a positive 36. These two are supposed to cancel each other out because we're not allowed to have I terms on the bottom. And then 36 plus 36 is 72. That would be your final answer unless 48 and 72 have anything in common.
They could be divided by 12.
I wish I would have
They actually get divided by something even bigger than 12.
24?
Yep. Now, if you didn't know that, I mean, you guys, is this top number smaller than the bottom? Pick up your calculators. Pick them up. Type in 48, ABC, 72. It reduces it for you.
-48 divided by 7.
No, don't even put the negative sign there. Just put 48, hit the ABC button, and then 72. And it says 2/3, right? So I know it's going to be negative, so I'd put -2i over 3. Now you said 12 at first. If you had divided by 12, this would have been -4 over 6. And then they're still even, so you could have just cut them in half at that point. You would have had to reduce twice. The calculator can reduce it.
I wasn't thinking of.
Yeah, well, most people wouldn't think of 24. All right, last page, and then I will set you free. Well, it's already been an hour and 10 minutes on the recording, hour and 9. Okay, number 19 here is number 21 on your test. Now what they have done is it says here A quadratic can be written in several ways. Give an example of the benefits of each form. Write using complete sentences. Okay, personally, I don't care if it's a complete sentence or not. I'm just going to tell you the reason why this is nice. The reason this is nice is because, like, when we normally make our asterisk and we get our two sets of parentheses, like they've already done, they've already factored for us, doesn't that give us our two x-intercepts? Like if I set this equal to 0, I'd have my two x-intercepts, wouldn't I? Okay, so intercept form, this is called intercept form, allows us to find the two x-intercepts. The two x-intercepts, people, are your roots or your solutions. So that form is super useful because it gives us the two roots. So we know exactly where it's already going to cross the x-axis at. Now, what did I tell you about standard form earlier? Standard form doesn't give us the vertex. What does it give us in that equation? What's this number right there?
The Y-intercept.
The Y-intercept. So standard form gives us the Y-intercept. Good Lord. So the Y-intercept, remember, is the constant. So that -6 right here, since it's the constant, that is our Y-intercept. You can pretty much guarantee that you're going to be writing the same stuff tomorrow because they're going to give you one in intercept form, one in standard, one in vertex. So it's basically the same stuff.
She has to go to work and make sure.
Vertex is easy. It just gives us the vertex.
Exactly. So the vertex form gives us the vertex without using a calculator, right? Gives us the vertex without the calculation. Yeah. You just have to remember to make that the opposite and that the same. But right off the bat, you already have the vertex.
So we're writing this on the test.
Mm-hmm. Yeah, because they're going to give you one of each form. Now, they may not be in that same order, you know. So if standard form is first, you'd want to make sure you tell me about standard form. Yeah, it's 2:04, but I'm not giving you a break. We're just going to finish because then you get to leave. All right, number 20 is number 10 on the test. Are you on vertex form?
Yes.
Okay, that's fine. Just I'm not moving it up anymore. You'll still be able to see that. Mm-hmm. You could be turning that volume down. Could turn it on silent like you're supposed to. Now, if this is standard form, there's only one way to find the vertex.
Ain't that asterisk?
No.
Negative B.
You got to do the axis of symmetry first and then a plug and chug. You've got to do the negative b over 2a to get x, and then we'll do a plug and chug. So it's a two-part.
So B.
Opposite of b.
Would be 8.
Yep, and then 2 times 1 on the bottom. So this is what we know. We know that the x-coordinate of our vertex is a 4. And then to find the y coordinate, it's a plug and chug. We go back to this, and wherever you see the letter X, we are going to plug in a positive 4. And that's just done on your calculator. And you should get negative 24. Last two problems. These are the and the or problems. The inequalities.
That's what I was.
Yeah, that's what I thought you were talking about. Now these we will write in interval notation. All right, greater. You might want to go ahead and write this. That's and then less than is or. One other thing I want to talk about. Remember when we write our final answer, if there's an equal sign, remember we use the square bracket? And when it doesn't have an equal sign, it's a parenthesis, right? And if you have to use infinity symbols, you'd have parentheses around those because, yeah, okay. Now it's all coming back. That was like early last week. So it's been a while. All right, so we're still going to factor just like we would. Like your first step is still to just do an asterisk. And you guys are pros at these. Oh, by the way, these are numbers 7 and 8 on your test. It's the last two problems that we haven't covered yet. 7 and 8. But you do your asterisk, and we've got a 12 and an 8. Which is 2 and 6, right? So x plus 2 and x plus 6 in parentheses. And we would have to set those equal to 0, just like we always do. So then you guys should be able to just go straight to your two answers. If they're both positive and the asterisk, our two answers are both negative. So if you guys think about and inequalities, the shading goes in between two numbers. So these are our end points. Which one is smaller? Okay, you'd have to put the -6 first, then the -2, and then the square brackets. Square because there was an equal sign. If there was no equal sign here, you guys would have it in parentheses instead of square brackets. So that one's done. Yay, last problem. It'll be an hour and 20 minutes it took to go through this. That's a record. I don't think I've ever had a video that long. Yeah. I should just be a YouTube star, huh? I know. Nobody wants to watch my Algebra 2 videos. All right, here we go. What makes -3 and -2? -3 and +1? No. No. I was trying to remember what Brittany had said.
I said 6.
I know, that's why I was like, what? I was confused. I was like, how do you make 3 and 2? And you said 6, so I know, it's fine. It's been a long day. So you have -3 plus 1 to make the -2 on the bottom, and -3 times 1 to make the -3 on top. So the -3 would become an answer of +3. And +1 would give you an answer of -1. Okay, so this is the one that's a little bit harder to write because it's an OR problem. So when you think back to Algebra 1A, when you did OR, If it had an equal sign, these would both get closed circles, but instead of going between, we go out. So if you think about negative infinity up to, which number is the smaller one? Okay, so we would have parenthesis for the negative infinity. I'm not grading you on how pretty your infinity symbol is, by the way. Up to -1, and because there was an equal sign, you got to put a bracket around that -1. Now the other section, you'd have start with a bracket, because then you'd start at +3, and we would go to positive infinity. So that would get the parenthesis. What goes in between there?
A U.
It's a U. It's a weird looking U. Yeah. That's your final answer.
Looks like you, the that person said.
Wait, so
I think it's like a symbol for like union or something. Okay, what were you gonna say? Now, if there was no equal sign, those would both be parentheses and those would both be parentheses. But because it had an equal sign, it's the square bracket. But don't go off running just yet.